as well, and then you could have some background kind of beneath the border. You'll see what I mean in a minute, but I'm kind of just explaining why we have these two images here. Then, of course, we have the white car. Again, this is just so you guys can have some options when we're using the cars. Great, so download all of those. Again, link in the description. It should download a zip folder, and then you can extract the zip folder, by right-clicking car class as well. Does not need to be able to reduce its speed. It's going to be the same speed the whole time, and so it makes sense to have this in the class where it's actually going to be used, because it's not going to be used by anything else that implements the abstract car class. You could leave it in there. There's arguments for both, but I am just going to move it here. Great, so everything will continue to work. We don't need to test that. Moving forward, though, the next thing I want to do is collision. So this is where we need to talk about masks, and we need to talk about how you actually handle collision of different objects in Python. So what I'm going to do is open up Paint here, and we're going to start talking about masks. All right, so I'm inside of Paint here, and I'm going to explain to you masks and how we do pixel perfect collision. So let's start with traditional collision, and then we can explain pixel perfect collision. So let's say we have some object, and let's just make it a circle for simplicity. Now remember, I told you that every single surface in Pygame is really a rectangle. So even if this is all that we're showing, we actually have a rectangle around this circle here. So we might not see the rectangle, and the reason we wouldn't see it is because all of these pixels here would be transparent pixels, so they wouldn't show up on the screen. Do it, which looks are overlap. Move the rect. These images are not touching each other. Two rectangles. And so how do we actually mask is transparent or present, whether it just exists, are overlapping into mask. Let's say we have a very simple image. Okay, I'm going to just go with a rectangle because it's easier here. And we have maybe something like this, okay? We have pixels all in here, pixels all in here, and then inside of the other two regions is transparent, okay? And now we have another image, and let's just do something like this, and maybe we only have pixels inside of this bottom left-hand corner. Well, the mask for these two images would look like this. It's just going to be an array, so we'd have a large array. It's going to be a two-dimensional array, and we would have 1, 0, okay? And again, excuse me, I'm using the mouse here, and then 0, 1, like that. Now for this image, it would be similar, but we're going to have nothing in the first row because we have no non-transparent pixels. Okay. Now let's imagine these masks are directly on top of each other. The two objects are completely on top of each other. Then what we would do is we would just compare values in these arrays and see if two 1s are at the same position, right? So we check here. So, okay, there's no 1 here. So we're not colliding in this region. Okay, then we go here. So, okay, there's no 1s there, so we're not colliding there. We go here. Okay, no 1s, we're not colliding. And boom, we find two 1s, which means we're colliding in this region right here. And so we would say, okay, yes, we are colliding because two pixels that are not transparent are touching each other. There you go. Perfect. That's all you need to know. However, it gets a little bit more complicated because we need to know the location of both of these masks before we can do this comparison. In the example I just showed you, we just imagined they were on top of each other. So if I select this and I grab it, it's going to be a bit rough, but we imagine this mask was right on top of the other one. And in that case, it was really easy to check if they were colliding. But what if the mask is sitting somewhere like this, or sitting here, or sitting up here? Well, we need to know that, and that's known as the offset. So we have something, and actually let's make a new file here. We have something known as our calling mask, and then I guess the mask that it's being called on. So let's say that this here is our calling mask, and then this is the mask that this mask is being called on. Well, we need to determine the difference between the top left-hand coordinates so that we can overlap these masks in the appropriate region to determine if pixels are colliding. So I want to calculate the displacement in X and the displacement in Y, so then I know the total displacement, and then I can align these masks properly before I do the collision. So if this is my calling mask, and this is the mask that I want to find the offset on, well, I just need to find that. I'll show you how we do that in code, and then that's one of the values that we need to pass to kind of our mask collision function so that we can overlap these masks in the correct area. All right, that's my explanation of masks. Hopefully that was good enough for you. Now we are going to actually do this. First thing we need to do, though, is create masks. So to do this, we're going to say track underscore border underscore mask. Now, this is the whole point of having this track border, is that we're going to use this border. Let's go to it quickly here as our mask. This will be one mask, and then we will compare this to the car, our player car, and we will see if these two masks are colliding with each other. And this is actually really easy to use because its corner is 0, 0, right? Its top position is 0, 0, which actually just makes it way simpler for us to do the offset calculation. So I'm not going to do scale image. I'm going to do pygame dot, and this is going to be mask dot from underscore surface, and we're just going to pass in here the surface we want the mask of, which is our track border. Easy enough. That's how you get a mask. Okay, so we have that of which is our track. Track border. Easy enough. That's how you get a mask. Okay, so we have that mask. Now what I want to do is make a method inside of my abstract car class. It will go inside of abstract car because this is going to be for both the computer and my player. And I will call this collide. Now we're going to take in self mask x equals 0 and y equals 0. With the point being, we are going to pass some other mask here. We'll generate a mask for our own image. We will then have the x and the y of the other mask. We obviously already have the x and the y of the car. We will determine if two masks are colliding in here. So I'm going to start by saying car underscore mask is equal to pygame dot mask dot from underscore surface. And this will be self.img, so whatever image we're using for this car. Then we are going to calculate the offset. Now the offset needs to be integer values, so keep that in mind. So I'm just going to say int like this. And the reason we need that is because we could get some floating value when we do this subtraction. But we need to calculate the offset x and the offset y. Now the offset is relative to the calling mask. In this case, we're going to say, I guess, collision, or we'll actually go with POI, which stands for point of intersection, is equal to, and then this will be mask dot, and I believe this is called overlap of the car mask with the offset. So we're going to use the other mask as the calling mask, which is going to dictate how we calculate the overlap. If we did it the other way, we need to flip the the offset, sorry. Okay, inside of int, I'm going to say, we're going to go with x minus self.x and y minus self.y. Whereas the other way around, let's see, of course, I've done it incorrectly. It's going to be the other way around. It's going to be self.x minus x and self.y minus y. Okay, so the reason why we're using this as our offset, again, is because the calling mask is the other mask that we're passing. So we're going to take whatever our current x position is and whatever our current y position is, and we're going to subtract that from the x and the y of the other mask. Now that will give us the displacement between the two masks. If we did this the other way around, that'd be fine, but we would then have to swap this and say the car mask is calling the other mask, okay? So that's how that would work. Hopefully that makes a bit of sense. The reason we're converting this to int again is because we need integer values for the offset. We cannot have floating points, and our self.x and self.y can be floating point values. Okay, so now that we have that, this is going to return to us the point of intersection between these two masks if there is one. Now, we don't actually care what that point is, at least not right now. We're just going to return the POI. Now what we can do to determine if two objects have collided is we can see if the POI is equal to none or not. If there is no POI, the two objects didn't collide. If there was a POI, then they did collide. So now we have collide, so I'm going to go inside of here, and I'm going to check for this collision. So I'm going to say if, and we're going to go car underscore player dot collide, and we're going to do this with, what mask was it? This was going to be the track border mask. And notice that I don't actually need to pass an x and a y here because the track border is positioned at 0, 0. Now, we actually haven't even drawn the track border, but that's fine because we don't need to. We don't need to draw the track border right now because we just know that it's going to be at the exact same position as where our current track is on the screen, because the track border and the track are the exact same size. They're pretty much the same image, except one is just the border. Because we don't need to. We don't need to draw the track border right now because we just know that it's going to be at the exact same position as where our current track is on the screen, because the track border and the track are the exact same size. They're pretty much the same image, except one is just the border, the other is not. So we don't need to draw it, but we can still use the mask, and we know its location is going to be 0, 0. Okay, so we have that. If player underscore car.collide track border, we can say does not equal none there. Then what we can do right now is we can just print collide. And that way it's really easy for us to see if we actually have collided. We can just look in our console and see if, well, we had a collide. So let's run this, and pygame.surfaceObject has no attribute overlap. Okay, let me go here. Okay, car mask, pygame.mask surface, mask.overlap. Surface object has no attribute overlap. Okay, let me go here. Okay, car mask, pygame.mask surface, mask.overlap. I realized what I did here. I passed the track border when I meant to pass the track border mask. Okay, so make sure you've actually passed the mask. That was the point of creating it. Let's run this now. And okay, we're all good. So now watch what happens when I go into the wall. Notice I get a bunch of collisions, and then when I get off the wall, it stops for a second. And if I go back to the wall, it continues printing collide. Now you can't really see it because my whole console's filled with collide, but let's quit this and clear and run again. And I'll show you, let's turn and let's go here. And then we get a bunch of collides as soon as we hit the wall. Okay, so that is the idea behind the collision. That's really all you need to know for calculating collision. Now that we have done that, we need to do something when we hit the wall. We can't let our car drive through the wall. So what I'm going to implement now is a bounce. So if you hit the wall, you're going to bounce off the wall with the same velocity that you hit the wall with, right? I guess we could go into the laws of physics, laws of motion, maybe is what it's called. If you hit something with a certain velocity, then you're going to go back in that same direction, right? Just like when you throw a ball off of a wall, it comes back, and you're going to lose a bit of velocity, but point being, law of physics. I won't explain more than that. So inside of my player car, I'm going to implement a method which is going to be bounce. I'm going to say define bounce self. Now, all I need to do inside of bounce is I just need to reverse the velocity. So I'm going to say self.vel is equal to negative self.vel. Now, this will work if we're going backwards or forwards, because if we're going backwards, the velocity is already negative, so this will then make it positive, so we go forward, and if the velocity is positive, then it just makes it negative, right? And then, of course, Of course, we'll just say self.move so that we start moving as soon as we reverse the velocity. So now all we need to do is here say self.bounce. And now if we hit a wall, we just bounce. And sorry, this is not self, this is going to be player underscore car. So if we hit a wall, we collide, we just bounce backwards, and we'll go in the same, well, actually the complete opposite direction as the one that we hit the wall at. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is Algo Expert. Algo Expert is the best platform to use when preparing for your software engineering coding interviews. They have over 160 links at the platform. So let's try it out and notice that I am bouncing off the walls. There you go. That is what I would expect. Now, this is a little bit glitchy, I won't lie. This isn't always going to work perfectly every single time, and you'll notice that sometimes you will kind of hit a wall even though you don't really see a wall. That's just because my image is kind of messed up a little bit the way that I had it, and so you might be hitting some pixels that you can't actually really see. Anyways, this is working good enough for me. I'm happy with the bounce, and so we're going to move on to the next thing. Okay, so we have now handled the collision with our walls, and you'll actually notice now that you can't go outside of those bounds because, well, you just can't, right? If you hit any of the walls, then you're going to bounce back inside. So now we need to make it so that you can hit the finish line, right? So let's start drawing the finish line on the screen. Let's handle collision with the finish line, but you'll notice that this is a little bit trickier than it seems because we have to know what direction we cross the finish line from. Because if the finish line is where we start, right, kind of starting line, finish line, if we just drive directly backwards, we can't say that we've won the race. We have to hit it from the other direction, so we have to handle that. Okay, let's go here, though. We have finish. Now, let me see if I need to scale this rather than just messing around with it. Let's see if I did scale it in my my code previously. Looks like I did not scale it, so that's good. We can just leave it where it is. But I do need to determine the position of the finish line. So I'm going to say finish underscore position is equal to, and I've already figured this out for you, it's going to be 130 and 250. So now let's just draw this in that position, and let's see what it looks like. So I'm going to any of the walls, and you're going to bounce back inside. So now we need to make it so that you can hit the finish line, right? So let's start drawing the finish line on the screen. Let's handle collision with the finish line, but you'll notice that this is a little bit trickier than it seems because we have to know what direction we cross the finish line from. Because if the finish line is where we start, right, kind of starting line, finish line, if we just drive directly backwards, we can't say that we've won the race. We have to hit it from the other direction, so we have to handle that. Okay, let's go here, though. We have finish. Now, let me see if I need to scale this rather than just messing around with it. Let's see if I did scale it in my my code previously. Looks like I did not scale it, so that's good. We can just leave it where it is. But I do need to determine the position of the finish line. So I'm going to say finish underscore position is equal to, and I've already figured this out for you, it's going to be 130 and 250. So now let's just draw this in that position, and let's see what it looks like. So I'm going to go to my So now let's just draw this in that position, and let's see what it looks like. So I'm going to go to my images here, and I'm going to add that as one of the images. So I'm going to say finish. I'm going to draw this at the finish underscore position like that. So now let's run the code, and let's see what we get. Notice the finish line is right here. All right, so there you go. The finish line is up. Now this looks fine. However, we can see it is kind of overlapping with our track. So what I'm going to do is just draw the track border over top of this. So that way we get rid of any of these edges that are being cut off. So this is kind of a neat solution that we can go with here. But what I'm going to do is just add inside of my images here. And make sure you do it after the finish line, by the way. Otherwise, it won't go over top of the finish line. I'm going to say track underscore border. And we'll just draw this at position 0, 0. Not 0M, 0, 0. Make sure we add our last bracket there. And let's run this now. And parentheses. Does not match. Did I mess something up? Okay, that looks good. All right, so now let's see this and notice that now the finish line is no longer overlapping. The reason for that is it is actually overlapping, but we're just drawing over top of it just the track border. So that way, everything looks good. And then there. There you go. Our car is now moving around. Let's see if we bounce, and we do. Sweet. Okay, so that is good. Now that we have done that, we want to handle colliding with the finish line. So now we're going to do another thing down here. We're going to say if player underscore car dot collide, and now we need to get a a mask for the finish line. So let's generate a mask for the finish line. We'll do that from up here. Where is the finish line? Right here. Okay, we're going to say finish underscore mask is equal to pygame dot mask dot from surface and then finish. Okay, we now have the finish mask dot mask dot from surface and then finish. Okay, 2pygame dot mask dot from surface and then finish. Okay, we now have the finish mask. So now we're going to say player_car.collide. We're going to go with finish_mask. And then we need to pass the finish position, but with an asterisk. What this does is split the tuple that is storing this position, so x and y, into two individual coordinates, and passes this to the function as two arguments. So if you do asterisk finish position, this is the same as passing 130 and 250. Okay, they're identical, but I figured I would show this to you because it's interesting Python syntax. Anyways, we're going to say again, if that is not equal to none, then what we want to do now is just print finish, okay? So now let's see if we can check for collision with the finish line. So I'm just going to go backwards, and notice we get a bunch of finishes. And then if I go up here, we get finishes again. So the thing is, as I was saying, we don't want to be able to just drive backwards and say, oh yeah, you finished. In fact, if we drive backwards, we don't want to be able to go past the finish line. We should only be able to go forward on the track. We shouldn't be able to go backwards and cross the finish line. So this is where I'm actually going to use the point of intersection to determine what direction I hit the finish line from. So rather than just printing finish here, I'm actually going to store this. And I'm going to say finish POI collide. Yeah, I guess that makes sense. Finish point of interest collide is equal to that. And then instead of all this, we'll just say finish POI collide, and we will print out the finish POI collide. Okay, so let's run this. And now let's go backwards. POI collide. Okay, so let's run this, and now let's go backwards, and notice that we get a bunch of zeros as we're going backwards, right? So if I keep going back here, let's go back, back, back. Let's just go slow here. Notice all of these are 0, 0, 0, 0, okay? And then as soon as, I guess, the top of my car kind of gets to the middle of the finish line here, we get some actual values for the y coordinate. So what we can do is we can just check if the y coordinate of the point of intersection is 0, and if it's 0, that means we hit it from as well, and then you could have some background kind of beneath the border. You'll see what I mean in a minute. Exactly what we wanted. Now we can just implement what happens if we cross the there. Last two. The other direction. And a bounce, meaning we're going to bounce just one. We're going to say if then car up bounce. Let's run this finish line from the wrong direction. Now let's go all the way around because I'm trying to cross the finish line from the wrong direction. When I go backwards now, I'm backwards trying to hit the finish line. Let's run this. Notice when I go backwards now, I bounce forwards because I'm trying to cross the finish line from the wrong direction. So if I keep y collide. Okay, so let's run this. Finish point of interest collide. Determine what direction I hit the finish line from. So rather than just printing finish here, I'm actually